In this video, we are going to talk about the derivative. Now, this is one of the key concepts for calculus and will be one of the key concepts and one of the key tools we use in this course. So we start by talking about the average rate of change for a function. So if we have a function y equals f of x, the average rate of change from x equals a to x equals a plus h is the difference quotient, which you've seen before. It is f of a plus h minus f of a divided by a plus h minus a. This is the slope, not of the function, but the slope of a line, rise over run. And we can simplify this a little bit to be f of a plus h minus f of a divided by h. Now visually, we can see here's our function in blue. We draw a line going through the points f of a and f of b. And we can see the slope of that line is f of b minus f of a over b minus a. So that's the average rate of change. And again, we can write that as the difference quotient. So let's do an example. A company's determined a price-demand relationship for the widgets they produce to be P equals 120 minus 4x, where P is the price, X is the quantity demanded, and X has to be between 0 and 30. And we want to find the average rate of change if if production changes from 12 to 15. So let's work through this problem. First, we need to think about revenue. So revenue is equal to price times quantity. Price, we know, is this formula up here, so that's 120 minus 4x times x, which is 120x minus 4x squared. The average rate of change is r of 15 minus r of 12 divided by 15 minus 12. Okay, so we need a calculator. So it is for 15, 120 times 15 minus 4 times 15 squared, which is 225, 900. So the revenue, if we produce 15 widgets, is 900. So this is equal to 900 minus the revenue for 12 widgets, 120 times 12, minus 4 times 144, 864. 864, all divided by 3. That is 36 divided by 3, which is 12. So this is the average rate of change in revenue. So on average, revenue changes by $12 per widget when production increases from 12 to 15. Okay, so that's our answer to this question. And of course, when we increase from 12 to 13, we end up with a different increase in revenue than 13 to 14 and 14 to 15, but on average, revenue changes by $12 per widget when production increases from 12 to 15. Now, we can also define the instantaneous rate of change. Again, given y equals f of x, the instantaneous rate of change is when we make h really, really small. So we take the limit. The limit as h goes to 0 of f of a plus h minus f of a divided by h, assuming the limit exists. Again, this is the slope. This is the slope of the tangent line at the point a, f of a. And we'll see that later in class. So again, pictorially, what are we doing? We're making h really, really small. We're going from f of a up to f of a plus h, and we start with some big distance, and then we make it smaller and smaller and smaller and smaller, and eventually we end up with our limit, and the limit is the slope of the tangent line. Now, we call this the derivative. So for if y equals f of x, we define the derivative of f at x, denoted by f prime of x to be the limit as h goes to 0, f of x plus h minus f of x divided by h, assuming it exists. If it exists at a point A, then we say f is differentiable at A. If the derivative exists at every x in some open interval, then we say f is differentiable on that open interval. If the derivative exists for all possible x, then we say f is a differentiable function. If the limit does not exist, then we say f is not differentiable at A, or f prime of x does not exist at A. Okay, 3 interpretations. Again, they all roughly mean the same thing. So first, the derivative of the function represents the slope of that function at some point. It's known as the instantaneous rate of change of the function. And finally, in physics, we won't use this, but in physics, if a function represents the position of a moving object, then the derivative represents its velocity. Okay, finding the derivative. This is a 4-step process. It's straightforward, and you're taking that limit, so it's just the steps in finding the limit. First, find f of x plus h. Second, find f of x plus h minus f of x. Third, find f of x plus h minus f of x divided by h. And fourth, take the limit. So we are going to find, and next week we'll find easier ways to take the limit, but right now this is how we're going to do it. Okay, first example. Find the derivative of the function f of x equals 2x plus 2. So step 1, we want to calculate f of x plus h, which is simply 2 times x plus h plus 2. Again, these parentheses, I cannot stress enough, these parentheses are really important to get right. If you leave out the parentheses, you make mistakes. 2x plus 2h plus 2. Second, f of x plus h, minus f of x is 2x plus 2h plus 2 minus, again, parentheses, 2x plus 2. Let's simplify. The 2x cancels out, the 2's cancel out, and we're left with 2h. Step 3, f of x plus h minus f of x divided by h, which is 2h divided by h, or just 2. And step 4, limit as h goes to 0, f of x plus h minus f of x divided by h, which is the limit as h goes to 0 of 2, which is just 2. So the derivative of this function, f prime of x, is 2. And again, if we look at this function is a line with slope 2. So it makes sense. On to example 2. This is a little harder, but again, not too bad. So we want to find the derivative of the function f of x equals x squared minus 3x. 4 steps. 1, find f of x plus h. That's x plus h squared. Be careful with your parentheses. Always worth putting them in. Minus 3 times x plus h is equal to, multiply this out, x squared plus 2xh plus h squared minus 3x minus 3h. Step 2, f of x plus h minus f of x. This is equal to, result of the first part, x squared plus 2xh plus h squared minus 3x minus 3h minus, parentheses, x squared minus 3x equals, first term cancels out, the 3x cancels out, we end up with a 2xh plus h squared minus 3h. Step number 3, divide by h. F of x plus h minus f of x divided by h equals 2xh plus h squared minus 3h, result of the second step, divided by h equals 2x plus h minus 3. Step 4, limit as h goes to 0, f of x plus h minus f of x divided by h equals the limit as h goes to 0 of 2x plus h minus 3, which is just 2x minus 3. So f prime of x is 2x minus 3. On to our last example. Find the derivative of f of x equals 1 over x plus 4. I think I'll not bother writing out all of the steps. F of x plus h, that's 1 over x plus h plus 4. Step 2, f of x plus h, 1 over x plus h plus 4 minus 1 over x plus 4. Typically, if you've got the difference of two fractions, find a common denominator. So, common denominator here is x plus h plus 4 times x plus 4. So in this first term, this turns into an x plus 4. Right, we've multiplied by x plus 4 over x plus 4 minus x plus h plus 4 divided by x plus h plus 4 times x plus 4. Again, simplify. The x's cancel out, the 4's cancel out. We end up with a minus h all over x plus h plus 4 times x plus 4. Step 3, divide by h. Minus h all divided by x plus h plus 4 times x plus 4 all divided by h is just minus 1 divided by x plus h plus 4 times x plus 4. Step 4, take the limit. As h goes to 0 of our stuff, this term here from step 3, and we can see there's only one h that appears, and when that goes to 0, we end up with an x plus 4. So we get minus 1 over x plus 4, the quantity squared. So f prime of x equals minus 1 over x plus 4, the quantity squared. And I promise we will get to the point where this is an easier derivative to take.